Hello students! So this is part 2 of solving quadratic equations by completing the square. In this video, again, we just want to go through a few more examples. Again, in part 1 video, we laid out exactly what it means or what the phrase completing the square means. In part 1, we looked at what things you need to do before technically completing the square, and what steps it takes to actually complete the square. And then we also looked at what it is that you need to do after you complete the square when we're talking about solving the quadratic equations. So again, with this one, let's look at a few examples. So in this example here, let's say that we're looking at solving negative 2x squared plus 128 equals negative 24x. So in a case like this, and so this is example A, example 1, example A, or whatever you want to call it, A, B, C, easy as 1, 2, 3. Alright, so in this example, we want to, again, this is a video about completing the square or solving by completing the square. So remember that the first step, or that the first thing we want to do or make sure that we do is we need to check to make sure that if the value of A is not 1, then we need to go ahead and divide every term in this equation on both sides. Divide every term on both sides by that value of A. And again, in this particular example, the value of A is not 1. So let's go ahead and divide both sides, every single term on both sides, by A. So again, let's go ahead and do that. So hopefully you all can tell based on, or in this form, hopefully you all can tell exactly what the value of A is. Again, usually when an equation is in standard form, where at least all of the terms are on the same side and is equal to 0, you can tell what A is. But again, this particular equation is written in, right now it's not in standard form. The B, that term in the middle with bx is technically on the other side of the equation. Right now it's sort of written in this form where we'd have to actually move, this middle term over to the left side of the equation in order for it to technically be in standard form for quadratic. However, we can identify what A is. In this particular case, our A value is negative 2. And so our A value is clearly not 1, okay? So we need to divide every term by that A value. So let's go ahead and do that. Negative 2x squared, we divide that by negative 2. We've got the 128. We're going to divide that by negative 1 by negative 2. We've got the negative 24x. We're going to divide that by negative 2. And let's simplify. So when we divide that first term, okay, let's try that again. When we divide that first term, a little bit better, the negative 2's cancel out, and we're left with x squared. When we divide this next term, just going in order from left to right, 128 divided by negative 2 is negative 64. And then when we divide that last term by negative 2, negative 24 divided by negative 2 gives you positive 12. And of course that's still 12x there. So we have divided each term by A. Now we've created a new equation where in this new equation now our A value is 1. Alright? And so now what we need to do is we need to go ahead and make sure that our terms with variables, the terms that have variables, make sure that they are isolated on the same side of the equation, and make sure that the constant term or constant terms are on the other side of the equation. So again, we need to isolate our terms with variables on one side of the equation, and make sure that the constant terms are separated on the other side of the equation. So let's go ahead on and start using some inverse operations so that we can get all the terms with variables on one side. So and it doesn't matter which part you do first, but let's get all the terms with variables on one side. So let's get this 12x moved to the left side, so that then at least all of our terms with variables will be written together on the same side of the equation. Okay, so let's subtract 12x on both sides. That leaves us with x squared minus 12x minus 64 equals 0. And so that's part of it. We've got all our terms with variables on the same side, but we need to get the constant term. And hopefully you recognize that negative 64 is a constant. Remember, a constant is a term that's written without a variable or without variables. So we need to get that constant term, negative 64, moved to the opposite side, to the other side of the equation. So let's do the inverse operation. Let's add 64 to both sides. Plus 64 plus 64. It cancels out here on the left side with the other 64 with the opposite sign. And we're left with x squared minus 12x equals 64. Now we have got our equation arranged in just the right way for us to actually complete the square. So when we're completing the square with this particular equation, what we need to do, or the first step in us actually completing the square, is we need to go ahead on and identify that value of b, that b value, and remember, we're not looking at the original equation, but we're using this new equation that got created after we made sure that the a value was 1. So again, we're using this new equation where the a value is 1, and in this equation, let's identify b. After we identify b, that value of b, we need to take that value and we need to calculate b divided by 2. And once we've calculated b divided by 2, let's square that quantity. Square whatever the result is of b divided by 2. And whatever that result is, we need to take that number and we need to add it to both sides of your equation. Alright, so let's do this. So again, we identify our b value. Whoa, okay. Alrighty then. Where were we? So again, we identify our b value here, and that b value for this new equation is negative 12. Again, hopefully you recognize that. And so again, the b value here for this new equation is negative 12. And again, that's the term that has the x, the coefficient for the x, not the coefficient for x squared, but the coefficient for x. That's the value of b that we're talking about. Negative 12 there. All right, so we've identified that value of b. What we need to do is calculate b divided by 2. We need to calculate the quantity of b divided by 2, and we need to square that number. So b divided by 2 is negative 6, and then we need to square that number. So we need to square that, and so that's b divided by 2 squared, which means we are doing technically negative 6 squared, which is positive 36. Alright, so what we need to do after that is, now that we've got this number, we've got the quantity of b over 2 squared, we need to take that number, that 36 in this particular example, we need to take that number there, and we need to add that number to both sides of our equation. Okay, so let's do that. Alright, let's take this equation, and I'm just going to write it one more time here. Just going to write it out there. That's x squared minus 12x. And again, since we're saying that we need to add that value to both sides, here's what I'm going to do. I'm going to put a little blank space here for us adding that value. Oh, wait a minute. And the number that was the number that's on both, the number that's on this side of the equation is 64. That new equation, and we're adding. So again, we're taking this value that we got from this last step, from us doing the b over 2 squared. We're taking that value, b over 2 squared, and we already calculated it, and we found that value was 36, right? So we're taking that value and we're going to add that number to both sides of your equation. Yes, we can do that, right? Because as long as we're keeping our equation balanced, okay, it is very much within the realm of something that we can do. All right, and in this particular case, we are doing it. Okay, so we're adding 36 to both sides of our equation. Let me just write that: x squared minus 12x plus 36, because that was the result when we actually calculated b over 2 squared. All right, and we're adding 36 here. That is the number that we're adding to both sides of our equation. Okay, so after we add that number to both sides, if it's possible, we should simplify or combine like terms. And in this case, it is possible to combine like terms on the right side of the equation. The expression on the left side does not have any like terms. Yeah, and remember guys, in one of the previous videos that I made for you, we had said that the only time you can combine like terms is when those terms are in, or when those terms are part of the same expression. And again, the only like terms that we have that are a part of the same expression are these two that are on the right side of the equation, 64 and 36. All right, when we add those two together, we get 100. All about the Benjamins. All right, so we get 100. And so we have combined those two like terms. After we have done that, what we need to do, or what we should do, is we need to rewrite this perfect square trinomial. And again, the whole reason why we added this thing to both sides of the equation, this b squared divided by, this b divided by 2 squared. The whole reason why we added that to both sides of the equation was so that we could get a perfect square trinomial expression written. And so now what we have here on the left side of the equation is a perfect square trinomial. And so we need to, in this next step, get this perfect square trinomial, this x squared minus 12x plus 36, we need to get that rewritten as a perfect square binomial. And it needs to be written in this particular form. It needs to be written as x plus b divided by 2, that quantity, squared. And so when we do that, writing that this perfect square trinomial here, writing that in this form, in the x plus b divided by 2 squared form. Remember, it's still an equation, and it's equal to 100. So again, folks, the number that we had calculated before was not b divided by 2. What we had calculated before, that 36, is not b divided by 2. The 36 was b divided by 2 squared. B divided by 2 was negative 12 divided by 2, which was actually negative 6. And remember, up there we had squared that negative 6. But down here, we're not asking you to square this number. We're just asking you to divide b by 2. So again, b divided by 2 is negative 6. Please do not put 36 there, because you will be wrong if you do that. Alright, so okay. Alright, so b divided by 2 is negative 6, and so that's what we're going to put here in this form. Now I know this says plus that, but again, and I'm going to erase this, but us writing plus negative 6 is clearly the same thing as minus, it's the same thing as minus 6. Okay, so that is x minus 6 squared equals 100. So at this point we have completely, or we have finished completing the square, because again, completing the square means writing it in a form where it's written as a perfect square binomial, and we got that. We got it written as a perfect square binomial. So now what we need to do is we need to go ahead on and finish solving this bad boy. No, we're not done solving. Yes, we've completed the square, but we still need to solve for x. So let's go ahead on and solve this by using square roots. Alright, so let's do that. Let's finish solving and by using square roots on both sides of the equation. Alright, so here, let's do that. Let's take the square root, okay, of x minus 6 squared. What we do to one side, we've got to do to both sides of the equation. Whoa. And so we got to take the square root of 100 as well. Alright, remember that again, when we take the square root of something that's being squared, it cancels out that square. Square root and square cancel out. The square root here acts as an inverse operation when you're taking the square root of something that is squared, or when you're taking the square root of a perfect square, or of something that's written as being squared. Anyway, it cancels there, and we're left with x minus 6. And on this side, we've got the square root of 100. Remember what happens when you're taking the square root, how many solutions you're usually going to have. Again, remember the only time that you do not have two solutions is when the radicand is 0, or when the number up under the square root is 0. That's the only time you're not going to have two solutions. But in this case, again, that number up under the square root is not 0. So yes, we've got two solutions, and yes, we need to write plus or minus. Alright, so x minus 6 equals plus or minus the square root of 100, and we still need to finish solving for x. We most certainly do, folks. So let's do that. Let's get x by itself. Let's use an inverse operation here. Let's add 6 to both sides. Again, folks, do not try to put together the 100 and the 6. You can't do it, alright? You just can't do it. Alright? You can't. Write them separately. These are not like terms, so please just write them separately. That's the square root of 100. It's not the same thing as 100. Alright, so this is x equals And again, you've got two ways that you can write this, but for right now I'm just going to write it in any old which way, because we still got to simplify this anyway. I mean, who's going to leave it in the form like this when we can actually simplify the square root of 100? I mean, come on, that would be ridiculous to leave it like this. You never leave it like this, not when you can simplify it. Okay, so let's simplify this thing here. And let's do it by taking the square root of that perfect square radicand that we see here. And again, so that perfect square radicand, or the perfect square, the number that's up under the radical, which is called the radicand, if you watched my video about using square roots to solve quadratic equations, and you know what radicand is. Alright, so that is 10, right? So the square root of 100 is 10. And so what we've got here is x equals 6 plus or minus 10. Again, remember folks that we're not gonna leave it like this either. This is two separate answers. Please do not just say, okay, well, this is 6 plus 10. Do you see a plus there, or do you see plus or minus? Yeah, exactly. I see it too. Good. I'm glad that our eyes work. Plus or minus. Two separate answers. One answer is with the plus, the other answer is with the minus, right? So one answer is where it is 6 plus 10, and the other answer is where it is 6 minus 10. Six plus 10 is clearly 16, folks, right? Two answers, two separate answers. So one answer is 16, and the other answer for x, because they're both the right answers, both of these answers satisfy the equation. And 6 minus 10 is negative 4, so they're both the answer here. Alright, and so let's look at a few more examples. Look at a few more examples here. Okay, so let's look at this example. So first off, again, if we're solving by completing the square, we want to make sure that the a value is 1, and in this case the a value is 1, so we don't have to worry about dividing every term by 1. And even if you did want to do the first step of dividing every term by the a value, dividing each term by 1, it would not make a difference. Why? Because when you divide by 1, nothing's going to change. So there's no need to divide by a when your a value is 1. So the next step again is for us to get all of our variables, or all of our terms with variables isolated, and then get all of our constants on the other side of the equation. Isolate all the terms with variables on one side of the equation, get all the constants on the other side. Alright, so now that we've got that done, and again we've moved the 41, that constant term, to the other side of the equation. Now that we've got that done, let's go ahead on and start completing the square. Let's identify our b value, and let's divide that value of b by 2, and let's square that. And then once we have the value of b divided by 2 and we've squared it, let's add that result, add that quantity to both sides of the equation. And that's going to get us where we've actually got a perfect square trinomial created. Okay, so let's do that. Again, our b value here is 14. Again, we're talking about the coefficient for the term that just has x in it. Not the term that has x squared, but the coefficient for the term with x. So b is 14. We take that, we divide it by 2. 14 divided by 2 is 7. And then we square that. b divided by 2 squared is the same thing as 7 squared, which is 49. So again, the number that we're adding to both sides of the equation is 49, and let's go ahead on and write that out. So we're taking the equation that we already had, and we're going to add 49 to both sides. X squared plus 14x, and we're going to leave a little bit of space there for that. Again, we're writing that out there. Okay, so again, we're adding 49 to both sides. X plus 14x plus 49 equals 49. Oops, sorry. Again, that number that was there in this equation, the number that was there was 41. So that's 41 plus 49. 41 plus 49, we're going to simplify that. 41 plus 49 is actually 90. And so we're going to combine these like terms because it is possible. 41 plus 90, 41 plus 49 is 90. So that's x squared plus 14x plus 49 equals 90. Now we want to go ahead on and rewrite this perfect square trinomial that we have here. We want to rewrite that as a perfect square binomial in this form. X plus b divided by 2 squared. We want to rewrite that perfect square trinomial here as a perfect square binomial in this form. And again, the equation is still equal to 90. So again, remember that b over 2 was not that 49 that we added to both sides. But again, remember that b divided by 2 was where we did 14 divided by 2, which is 7. Okay, so we're really writing this in the form of x plus 7 squared. And that's equal to 90. Alright, and so the last step for us to do, so now we've got it written as a perfect square binomial. We have completed the square at this stage, and the only thing left to do now is to solve for x. We finish solving by taking or using the square roots on both sides. Okay, so when we solve by using square roots, we're going to take the square root here on the left side of the equal sign, x plus 7 squared in the square root of that, and we also do the square root of 90 on the right side. Remember that when we take the square root of something that's being squared, the square root cancels out with the square, and they act sort of like inverse operations. They cancel each other out. So the square root and the square cancel each other out, and so there we've got what's left over is x plus 7. And remember, once those two cancel out, the square root and the square, you don't need the parentheses anymore. And remember here, there are two answers. The only time you've got one answer, the only time you've only got one answer is when that number, or radicand, when that number up under the square root is 0. But again, otherwise, you're going to have two answers, or a plus or minus symbol out in front of the radical. Alright, so here the only thing left to do to get x by itself is to subtract 7 from both sides. And remember, guys, that when we subtract 7 over here on the right side, you are not going to put this square root of 90 together with 7. You need to write it separately because they are not like terms. Gotta write it separately, okay? Alright, so these two cancel, the 7s, and we've got left that x equals, and I'm going to just write it like this, negative 7 plus or minus the square root of 90. Alright, so this is the answer. However, we still need to simplify the square root of 90. Whenever you can simplify a radical, you should. Again, whether or not you are simplifying writing it in its simplest radical form, or whether or not that number was a perfect square, the number up under the radical, or whether or not it was an imaginary number. So guys, really quick, just going to do a quick little insert because I'm not going to do an example with where we're simplifying it with an imaginary number. Remember, the only thing that would make it imaginary is if there was a negative number up under the radical. So the only thing that would make it, and I'm going to erase this after I write it, but just to remind you real quick, the only thing that would make it an imaginary number would be if it was a negative radicand, like something like this. So if we were doing that, remember this would be I times the square root of 90, and then of course you would still simplify that square root of 90. And again, I'm going to simplify that square root of 90 here as well. So again, the only thing that makes it imaginary is doing that. Okay, I am going to erase this imaginary part after I go ahead on and simplify this radical here. So we're going to simplify this radical. Remember, you identify factors of 90 where one of those factors is a perfect square. So that means that we're looking at the pair of factors of 9 times 10, right? So we're talking about the square root of 9 times the square root of 10. And 9 is a perfect square. And so we have identified those two factors of 90 where one of them is a perfect square. And now we simplify this radical. We simplify the radical there. The square root of 9 is 3, right? So the square root of 9 is 3, which means that when we simplify the square root of 90, it is really going to be written as 3 times the square root of 10. And again, it would work out pretty much the same way if this was an imaginary solution. This is just a reminder for you guys of how you would do it if it was imaginary. This would still wind up being 3 times the square root of 10. But again, since this would be I, then you would have to write it as 3i times the square root of 10. You would still have the plus or minus in front of this, and you would still have the minus 7 in front of this. But again, I just wanted to give you that reminder of how it would be done if it was an imaginary solution here. I'm going to erase all of this right here, all of that right there. Big eraser, big eraser. Awesome. Okay. All right. So these are your two solutions here. I'm going to call it. With this particular example. This is your answer, and if you were asked to write it as a decimal, the answer as a decimal, I'm going to ask you to look at some of the other videos that I've done on solving quadratic equations, where I have shown how to write your final answer as a decimal. Again, I'm running short on time, and yeah, that's about it. I hope that this video has been helpful to you with how to solve quadratic equations by completing the square. Again, this is part 2. There was a part 1 to this, but again, I hope this was helpful to you. That's all, folks.